Okay, dear friends, we all know that the success of any GIS project largely depends upon the proper method of data acquisition, processing, analysis, visualization, and presentation. Mistakes or errors introduced in any stage of the project may adversely affect the final results of the project. So we should be very careful while acquiring data from different sources. For the preparation of different types of thematic maps of Nepal, let us see where we can get spatial data for the administrative units of Nepal. For this, we just go to the website called National Geoportal, National Geoportal of Nepal. And this is a website developed by the Survey Department, the National Mapping Agency of Nepal, and there are many data made publicly available by the government of Nepal. So let us see what is available for our project. Let's go to this website. So when you go to this website for the first time, you will have to register yourself in this website. So this is the website, and for signing in or joining into this website, you will have to click here or here. Since let us try to sign in with my credentials. Let me try this one. I just sign in. I have registered before. Now I am in the website. Now for the fetching of the data, we can go to this data and metadata icon and look downwards. Follow downwards. There are different data available. Some data are freely downloadable, and some are to be paid. Let us see for the administrative boundaries data, and let us go downwards and try to download this administrative boundary Nepal local units at the scale 1:1 million. This is freely available data. Let us download the data by clicking here. So while downloading, you will have to agree to certain terms and conditions. I just agree with this condition and download the data. So my data is already downloaded. So it's here. I just quit from here. Let us see in my download folder, I have my data here, local units. So I can unzip this data to my working folder. For working in our project, I have developed a special folder for that purpose and named it practice. Here it is. It's empty. The folder is empty. Now I extract data from this downloaded files, extract data files to my practice folder, which is in D drive and the practice folder. Here it is. And I select this folder and extract all the data from this zip file. So I have my extracted data here inside Nepal local units 0.zip. So now I go inside this and we can see 5 shape files. So let us extract these files, copy these files in practice folder. So once we have done this, we do not need these zip files for time being. So we just delete it. And we have these shape files provided by the survey department. If we go into the projection information file, we can see that the data have been projected in WGS84 datum system. So we should be very particular in checking all this data. The data itself, the errors in the data, and the projection systems, coordinate systems of the data. Otherwise, we will get missed out of all data. So now Now we have only shape files. It is better to have geodatabase and convert this shape file into geodatabase. So for this purpose, we just create, with the help of our catalog, we create a database in our folder D drive, in our folder practice. In practice, we create a new geodatabase, file database, and rename this database as practice. So the database has been created, and inside database we create feature data set. Say this is administrative data, and for this we define the projection system as Everest decimal degree system. So we are going to work in Nepalese datum system, Everest, that is Everest 1830 system, because I know that the data were created from the topographical maps which were made in the Everest datum system. So I prefer to work in the original datum system, coordinate system. So we create this Everest decimal degree system. Let's click next and finish. Now we have administrative data, what we call data set here. So we created this. Later on we'll have to use this folder. Now for now we have just created a database. So now let us open ArcGIS. You may have a different version of ArcGIS. I have ArcGIS ArcMap 10.8%. So it takes a few moments to open the database. So once it is open, so first of all, we'll have to work out with our downloaded shape files. So we know that the shape files were in WGS84 system. That's why we changed the coordinate system of our data frame into WGS84 decimal degree system. Okay, and load the data that we have downloaded, which is in practice, our practice folder. This is the shape file. We load it here. Now, once we load it here, we just are trying to convert this data into our Nepalese system, Everest datum. So for that, first of all, we have to save this data in WGS84 system. So it is done in the following way. Right click this layer, click data and export data. So now we export this data to my I have a separate folder also, geodata folder, and where in that folder I have geodatabase created for WGS84 also, geodata WGS84 system also. I click here, and since we are going to save this polygon, I go inside polygon and save the data Nepal local unit 0 as export. Okay, leave it the name, export output, let's say 0. So save it. Now the data has been exported to WGS84 system. So now we can quit here. Let us change this. Let us remove this data, and now let us change the projection system of our data frame, and let's go to Everest DD system. Everest DD system. Apply this. Okay, and now let us try to add the data we have in geodatabase WGS84 system. polygon, and export output. This is the same data that we have downloaded, but it's already in the system, file database system. Now add. So once we try to add a file from WS84 system into another system, in our case Everest system, we'll have to provide some transformation parameters. So that's what this software is asking. So we click transformation, and we are supposed to transform the data from WS84 to Everest DT system. So for this, we can have this transformation parameters. I already have entered it as a file. So this is 7 parameters, Bursa-Wolf parameters, and we are going to convert from CGS WGS84 to Everest DT. I select this one. So here are the parameters. You can note this parameter for future use as well. Once I select this, I click OK, and I close this dialog box. Now the data has been converted and displayed into Everest decimal degree system here. Yeah? So now we can transform this data once more, export this data, and save it at our practice folder. So let's go to D drive, practice folder, and practice database administrative. Now we can rename this folder as, let's say it's Palikas underscore area. This is the data layer we are going to save, Palikas underscore area. Save it. So click OK. So our data has been saved. We can add it to this data frame, remove the old one. Now, so until now we have done the downloaded data, transform the downloaded data into proper working system. So if we look into the data Palikas area, what we find is that we can go to attribute table of this data, and we can see the number of records available here. There are 777 records in this data, and we know that in Nepal we have only 753 local units. So there are some unwanted or unwanted polygons in the data. Let's check. There might be some. We can check it using different methods. So this Lumbini Sanskritic Development Area, this is actually not the Palika or municipality. It is just preserved designated area, this one. Similarly, there are other designated areas as well, which we call, which are mostly the national parks. For example, you can check it here. So these are the national parks, and this is watershed wildlife reserve. These are the wildlife reserve. So what else? Gaupalika. And these are the hunting reserves. So that's it. So out of 777 records, there are 22 records which do not represent the local level units. They are designated areas. So out of 777 minus 22, we get 755. So friends, there are still 2 more unwanted polygons in this record. We can just find it somehow. Let us see how to find it. Let us select Swiss selection. So let us check whether all are unique records or not. So this is Gaon Palika, it's okay. Gaon Palika. So this is just a way to find out the erroneous data. Nagar Palika. So it's most of the times it is not that simple to find out the errors in the databases. So sometimes it helps if we check it by the area shape. Let's say this shape area by shape area. There are some polygons with very small area. We can check these data in the data layer. So let us sort it by ascending. These are the two suspicious polygons. Let us check where they are. So this is also correct. This also this area belonging to national park. Yeah. So this is the one incorrect, and another one is selection zone. So here also we have. So in this area. So this also part of designated area. I think. So this is the way that we check for the errors, and after careful examination, we just remove such errors from our database. So I have done this already, just to save a little bit of time. So after doing this, I have saved my final data for this practice purpose into the video making folder, video making geodatabase, administrative, and Palikas. So this Palika, you see, I have already removed this. We had some error here in this part. Now after removing the errors, I have this polygon. So in this final layer, I have 771 polygons. That is we can check it now. 771 minus, if it is 22, 49. Okay. So if we check all this, so all these units, there are 18 units that represent different types of designated areas. Yeah? So 771 minus 18 gives us 753. That is the exact number of local level units in Nepal in our case. So friends, after this, once we have done this, in our previous downloaded data, if you check, we can see the following attributes in the attribute table of the data. We have state code, district name, Gaon Palika, Nagar Palika name, that is local level name, and type of Gaon Palika, Nagar Palika, province number or name, that's it. So in this stage, the data cannot be used to join with the attribute data from different other agencies, because we do not have any specific code for these local level units. So now I have added CBS LID, Central Bureau of Statistics local ID number field in this table and typed in the codes for these local level units provided by Central Bureau of Statistics. So I have done this because once we have done this with the spatial data, we can easily join our data with the information provided by Central Bureau of Statistics. So we're using this common code. So that's what I have modified in this data, and everything else is okay. So in this way we have processed the data and make the data fit for further processing to make different types of thematic maps. So friends, with this we have the spatial data of local level units of Nepal for making different types of thematic maps on the basis of different attribute data provided by different line agencies. So in next video we'll try to see from where we can download attribute data and use with our spatial data. Thank you for being with me. See you in next video. Thank you very much.